Very good morning, my dear friends. Myself, Professor M.H. Annaya, and in today's video, we are going to design a parallel fillet welded joint which is subjected to an axial load as shown in the figure. So we have a plate and it is being subjected to a load of 50 kilonewton. We have two welds, each of length L1, L1. And remember, generally in parallel welds, both the welds will have the same length. And if you want to increase the length, may have to just slide this plate to whatever the length you want and then make the welding. Friends, let's see what is the question in store for today's video. A parallel welded joint is to be designed for a load of 50 kilonewton. Taking the thickness of the plate, this is a plate to be welded and they give us the thickness of the plate as 15 millimeter and it has to sustain a load of 50 kilonewton, and we have been asked to determine the length of the weld required when the load is static and when the load is dynamic. Friends, all these parallel welds, when subjected to a pull like this, they fail by shear. So you should remember, parallel welds fail by shear and transverse welds fail by tearing. So you have to remember these two. So we are going to consider case A when load is static. Load is static. So what should be the length of the weld required to sustain this load? Friends, you can just take a small statement. The parallel welds are subjected to shear, and hence the shear stress tau is given by the formula P divided by 0.707 H into the total length, I will say twice L1, where L1 is the length of each weld. Friends, to find out this length of the weld, we have to know the value of shear stress, the load it has to sustain, and the thickness of the plate. We'll write down one by one, friends. In the question, they have given the shear stress as 75.8. In case it is not given, you will have to refer to the data handbook and get the value from the tables. So friends, here tau is equal to 75.8 Newton per mm square given. Otherwise, you will have to refer to table. And the value of P is 50 kilonewton, 50 kN. That is equal to 50 into 10 to the power of 3. And H is the thickness of the plate, that is given to be 15 mm. All these dimensions are in millimeter, 15 mm. Friends, you have to make all this substitution and get the value of L1, the length of each parallel weld. So friends, here tau is 75.8 is equal to P is 50 into 10 to the power of 3 divided by 0.707 into thickness of the plate is 15, and this is 2 times L1. So friends, you will obtain what is L1. L1 is the length of each of these parallel weld, and this given totally works out to the value 21.99 millimeter is the length of weld required in case of the static load. And friends, as usual, you have to add 10 millimeter extra for starting and stopping of the bead. Finally, adding 10 mm extra for starting and stopping of beats. L1 is equal to 31.99 mm. So on each side there should be a length of 31.99 and 31.99 millimeter. So friends, on the same lines, let us find out what is the length of weld required when the load is dynamic. Load is dynamic or fatigue loading. Friends, for this also we make use of the same formula, that is tau is equal to P divided by 0.707 H into twice L1. But friends, here pH all are same, but this tau is equal to tau actual divided by the fatigue stress concentration factor. Fatigue stress concentration factor. Friends, you know, the joints fail at a smaller value of stress when the load is dynamic, and this tau, whatever you are going to use here, should be divided by the fatigue stress concentration factor, and that is available in the machine design data handbook. So friends, it is not specified and its value is 2.7. So this is tau actual is 875.8, and this value of the shear stress is to be used here when the load is dynamic. So friends, if you use this value, you get 75.8 divided by 2.7 is equal to P is 50 into 10 to the power of 3 divided by 0.707 into H is 15 multiplied by twice L1. So friends, very obviously you are going to get this length a higher value compared to that of the length obtained in the case of static loading. Friends, this works out to 83.88 millimeter. And friends, you find it's almost 3.5 times more than that of the static load. Again friends, you have to add 10 millimeter extra for starting and stopping of beads for this length L1 obtained. And friends, this is how we obtain the length of weld required in static and dynamic loads. Friends, I hope the presentation was interesting. Please go through the complete video without fail, and if you like this video, please share with all your friends. And friends, if you have not subscribed to my channel so far, please do it at the earliest. Have a wonderful day.